All right, I think we're going to get started here. Thank you all very much for attending our webinar on best practices in responsible AI for defense and security. My name is Anthony Hoogs. I'm the Vice President of Artificial Intelligence at Kitware. With me is Dr. Brian Yu, who is a staff research and development engineer here at Kitware. I'll introduce himself in a moment. I've been working in AI and computer vision for my entire career, over 30 years now. For the last 6 years or so, I've been working in ethical and responsible AI, largely under funding and involvement with DARPA, and now more lately with the CDAO, Chief Digital and AI Office at the Pentagon. We'll talk a bit more about their role here. I've spent my entire career in computer vision, and ethical and explainable AI. As I mentioned, we started in about 2018, 2017, even here at Kitware in my own interests. The field has existed longer than that in the past. It's been going on for 20 odd years or more, but has really picked up a lot of steam lately as AI has grown in influence, popularity, and power. Concerns about it have grown as well. So there's a very active research community in ethical AI, AI regulation, AI assurance, all of these related topics. So today we're going to cover some of this, mostly through the lens of what Kitware has been doing in this area, which is in defense and security, largely funded by DARPA and a few other agencies in the Defense Department. So it is very focused here on security, but there's a lot of general principles around ethical AI and so on that we'll talk to. So that's a bit about me. I'll let Brian introduce himself.
Yeah, hi, my name is Brian Hu. I'm a researcher here at Kitware. My interests are also in ethical, explainable AI, and yeah, I'm happy to talk a bit about some of the projects that I've been working and leading since my time here at Kitware.
Thanks, Brian. So I see a lot of familiar names on the list. So thank you very much for attending. Please ask questions throughout. There is a questions button. You can put questions in the chat, but there's also a questions option as well on the upper right of your screen. There's both chat and questions. We'll be monitoring these streams, but questions will come to the organizers, to myself and Brian, without going to other attendees, and chat will go to the entire group. So you can choose accordingly when you want to ask a question. As we go through, I'll look at the chat stream and the question stream and answer questions. So don't hold them to the end. Please feel free to pop in with a question at any time. We have about an hour, and so we won't specifically save time for questions at the end. Hopefully we'll have dialogue throughout. We do have a little survey that we want you to take somewhere here in the middle. Okay, so let's dive in. Kitware, slide 2 there. So Kitware is an open source company, so we're a bit unusual in that we have, put it on the slide, there we go, one back. That's the slide, good. So Kitware as a company is an open source toolkit company. On the right is a listing of our open source toolkits around the outside of that circle. Inside the pink circle are our 5 technical teams. I lead the computer vision team, although we're much beyond computer vision now. And the other teams, scientific computing, medical, software solutions, data analytics, all do related things: visualization, medical image analysis, information and analytics visualization. One of the cores that binds us all together, though, is an open source philosophy. We don't develop or maintain intellectual property. So Kitware as a company creates toolkits, and we give them out freely to the world or to the government if they're access restricted, without claiming IP, with very permissive licensing. So our toolkits are used by hundreds of thousands, even millions of people around the world. They're used throughout various government agencies as well. Restricted toolkits and systems that we've issued within government circles are then given without intellectual property, with unlimited rights to the government. Therefore, can be reused easily without cost to the government on other programs by other performers, other government agencies, and so on. We have 5 physical offices, 4 in the US, shown here, Albany, New York, where I am, Arlington, Virginia, where Brian Hugh is, Chapel Hill, North Carolina, Minneapolis, and then 1 in Lyon, in France. About 200 employees. That number fluctuates, of course, but we're slightly under that right now. And we do a fair amount of secure work. So we have a secure facility in Albany, New York, and a number of cleared people to work on government projects. Obviously, today is completely public and unclassified, but we do, as a company, work at all levels of classified processing. We're mostly a federal contractor, 85 to 90% of our revenue coming from the federal government, the rest coming from commercial companies. We do commercial services contracts where companies, large and small, will come to us and ask us for custom modifications of our platforms or software that we can build given our expertise that companies may not have in-house. A wide range of government customers, largely the DoD, intelligence community, Department of Energy, National Institutes of Health, and Department of Commerce and NOAA as well. Next slide. So the computer vision team, the AI team at Kitware has been doing all kinds of different computer vision and now more broad AI work for about 17 years. We have about 60 members on the team. A little less than half have PhDs in computer vision or something closely related. So today we're mostly going to talk about the block in the upper right here, an ethical and explainable AI. But we do all of these other topic areas, and ethics, of course, and explainability can infuse throughout all of those. So it's really a cross-cutting element that might influence how one does object detection and tracking or threat detection, things like that. So we do a number of these different areas, a number of different projects, usually about 40 different projects at any given time, across a wide range of domains shown in this graphic here. We've processed video from the bottom of the ocean all the way up into outer space and pretty much everything in between at one time or another. We have open source toolkits created by the vision team shown in the lower right. In the slides, these are actual links here that you can go to any of these toolkits hosted on GitHub and show what we do in various ways for these different domains. So these toolkits embody things like 3D reconstruction from imagery and video, change detection in satellite imagery, maritime domain specific tools to build object detectors and classifiers in underwater video. That's the AMI toolkit, and a number of other things for video analytics and Quiver, 3D reconstruction and telesculpture and so on. Next slide. To do all this work, we generally have a lot of funding from the R&D agencies in the federal government and the Department of Defense, and that means we're collaborating all the time because typically on a nice effort, that's a big research program from, say, DARPA, DARPA, Air Force Research Lab. We will have a university or two or another company, an R&D company as a partner, where we're the prime or they're the prime, depending on the particular effort. These are the last 5 years or so of our collaborators. We typically are working at any given point in time with 20 to 30 different universities, shown there on the left. Our sponsors are in the upper right, most of them, and the lower right is our companies that we've worked with, typically in a direct relationship contractually one way or the other for the last 5 years or so. So we have a broad reach. We do a lot of work interactively across a number of these different communities. Next slide. So today we're going to talk about ethical AI, specifically within the Department of Defense, and how it has constructed policies and principles to guide ethical AI development. And then we'll talk about the case studies and the work that Kitware has done in actually doing ethical AI and building tools for this across a few different research programs shown here. The JADIC, ITM, and Azimuth programs are all ongoing and represent some of the most significant efforts that we're aware of in ethical AI across the DoD and the federal government that are currently actively funded. So to first introduce ethical AI and what it means to the Department of Defense. About a year ago, the Pew Center did a study, a public survey about concern in AI. And as AI has grown in its use and power and so on, concern has grown too, and grown rapidly. If we look here on the left, this is 3 years of study from 21 through 23. We've gone from a minority of people being more concerned than excited, 37%, to 52% being concerned about AI in daily life. So only 10% are more excited than concerned now. It's only 18% before, but it's shrunk almost by half to 10%. And 52% now are more concerned than excited. This was a year ago, so we haven't seen an update to this study yet, but it would probably show even more concern than excitement. And then breaking it down a little further on the right, we look at privacy and other areas of AI, how concerned versus excited are people, and this is in 2023. So people are more excited about AI helping to find products and services online than hurting. That was a pretty dominant majority for helping this top line here. The second line on the right there, keeping personal information private. Obviously, most people are much more concerned about AI there than they think it's going to be a positive influence. Safe cars and trucks, actually quite a bit of support for AI there. Some concern, a lot of neutral, 44%, but 37% of folks are actually positive on that. Doctors providing quality care to patients and so on. So you can go down the list here and look. And in general, there is a lot of positivity around AI in the population. It's not universally negative at all, but that concern has been growing. Okay, so now we're going to ask you to participate in a little poll here. So this was the public at large. But I'd like to get your opinion on some of these issues. So let's launch the poll. And you should see a poll question pop up that asks you about AI in diagnosing medical issues. So you get 3 choices here. Are you or somewhat excited? Are you equally excited and concerned? Are you somewhat concerned? Or very concerned about AI being used in the medical field for diagnosis. So please put in your votes here. I can see votes coming in. We'll give it another moment here, and then we'll tally up the poll. Okay, I think we've stabilized. All right. Last chance. 3, 2, 1. Okay, I'm going to close the poll. So 76% of you said equally concerned and excited. 24% of you said very excited or somewhat excited about AI in medicine. And 0% of you said very or somewhat concerned. All right, so you're all either equal or very excited about AI being used in medical problems. So that's great. Now, if we go back to the slides, this corresponds to a question here. This is generally the topic is about, in the same Pew poll, the topic is about AI systems, knowing people's thoughts, making life important decisions for them. And specific categories of this, one of them is diagnosing medical problems, here this third row. And there was a slight majority in this poll for being very or somewhat excited, and then about a third of the folks concerned. So you had, in our poll here, we had 0% concerned, and 75%-ish in the middle, equally excited and concerned, and then 25% over here. So actually lower on the very somewhat excited in this group, and then more in the middle, and then very few, and then 0 over on these, very or somewhat concerned. Not too surprising, given we're technologists generally here on this call, that we're not too concerned about it, and we're more happy and excited about the possibility. Particular areas where people were very concerned and are continuing to concern is growing, making life decisions that are important for people. It's a pretty generic question. Knowing people's thoughts and behaviors, that sounds kind of creepy, and nobody really, not very few are in favor of this. Last year, I was chairing a panel at the Winter Conference on Applications of Computer Vision. So in WACV, it's called. This is in early January, so about 10 months ago. And it had been about 2 months after President Biden and his administration issued an executive order to regulate artificial intelligence. And this regulation had a few different stipulations, but one of them was to require thorough testing and notification to the government if you created an AI model above a certain size, which was based on the number of parameters. And that was a pretty high bar. At the time, I think only 1 or 2 models actually fell into this category. Now there's a couple more. And I just did a straw poll in this session. There were about 800 people, 700 or 800 people at the conference in the room. And I just had people raise their hands if they agreed or did not agree with this order, right? Did they support this executive order? And I said, don't vote if you don't know about it. And about half the people knew about it. So maybe half of them didn't vote at all. But of the ones that did vote, 75% of the respondents did not agree with this. They did not want AI regulation, at least in the form of that administrative order, which was pretty surprising. So I think generally the AI community, this is my general sense of it, is that they are moderately against regulation. There's a hefty percentage that are very concerned about AI and its potential if it's unregulated. But I think the majority of AI researchers are not at all concerned about that and just want to run forward with AI. So I'm not going to get too ontological here, but ethical AI, what is it? There's various definitions. This is what Wikipedia says. But by and large, it's trying to get AI to follow ethical principles and morality that humans would create and understand. So following the system of the ethics of a culture. There's a bunch of ethical AI frameworks that have been built to try to embody this. So how should we define ethical AI more precisely and more computedly? And this was a terrific graphic, it's kind of old now, published in 2020 by Harvard, just before the DoD ethical AI principles came out. I encourage you to look at this in detail. But there's a whole bunch of ethical AI frameworks that have been published kind of around the world. And the color coding here is that green in the upper right is government. In the upper left, the yellow is civil society organizations, and the private sector is kind of the lower left there in pink. So the sort of segments, the pie slices of this represent the different types of organizations that have produced ethical AI statements. For example, Google, Meta, and so on, they all have statements about ethical or responsible AI, what they will do, what they won't do with AI, and things like that. And they've had them for years. They're interesting to read and look at. And they mostly follow the same kinds of things. But the factors that they have or consider are shown here in the concentric rings. So privacy is the innermost ring, accountability is the next one. The outermost one is international human rights, promotion of human values, and so on. It's the second one. And then for each point on the outer part of the circle here is one of these frameworks, the ethical AI frameworks, and then how much it includes or emphasizes each one of the factors, each one of those rings is the size of the circle on that ring. So it's a neat way to look at the difference between these in a very holistic, overall global view. Next slide. So in 2021, the Department of Defense published the ethical AI principles. They worked on this for a while, and there's 5 of these that they converged upon. And this is specific to the DoD. Responsible, equitable, traceable, reliable, and governable. And these are driving a lot of the development work on ethical AI in the DoD. So if you're working in the DoD in anything related to responsible ethical AI, it's important to know these principles and what they mean. Responsible is kind of a catch-all, but it's mostly about appropriate levels of judgment and care. DoD will use appropriate levels of judgment. This phrase appears throughout ethical AI work in the DoD. Equitable, avoiding unintended bias. There's almost always bias, but we want to avoid unintended bias. Traceable, can we know why the decisions by an AI were made, what factors were included, and so on. So explainability goes really under traceable. Reliable, does it do what it's supposed to do? Does it not do what it isn't supposed to do? And governable, can we control it? Can we avoid those unintended consequences and detect them and do something about it? Can we turn it off? Very important. Go ahead to slide 12. So the DoD, a lot of people don't know the DoD even has these principles, particularly when I give talks like this in the academic world. People are surprised that there's ethical AI principles within the DoD and that they're taken quite seriously, but they really are. And the DoD has always tried to adhere to the law of war, and we're doing so with AI. That's how we fight wars. We have a very judicial warfare system, more so than our primary adversaries. We have the DoD Directive 3000.09, for example, which governs autonomy in weapon systems, which we'll talk about in a minute. But in general, all of our folks in the military, whether they're new recruits in just privates in the Army or whether they're graduating from West Point, they're taught about ethical military ethics, the laws of war, the rules of engagement, and how they have to conduct themselves in conduct of war and active fight. Next slide. The Directive 3000.09 was created in 2012, has been updated in 2023. It specifically covers autonomy in weapon systems. So note that this predates the 5 ethical AI principles. It was updated in 2023 largely to say you need to adhere to those 5 ethical AI principles in 3000.09 as well, but specific to autonomy. So when we have a system that is making decisions on its own, it's an embodied weapon system in particular, so it has a lethal force or just the use of force, even if it's non-lethal. How do we make sure that it doesn't get out of control, that it's only used where it should be, and that appropriate level of judgment, human judgment, shows up here again, and it's repeated and emphasized in this directive. So we won't cover this too much today because the programs we're working on, except the new one Asimov does apply to autonomy in weapon systems, and other ones I have not worried about autonomy yet. Next slide. So ethical AI is typically applied and looked at across a range of potential users. So first, we're developing a system. Right? So somebody's creating some AI. Those are the developers over here. What should they do to be ethical about it? What ethical AI aspects apply to the development of a system and then testing of that system? So we have developers like myself and Brian who create these things, and then there's testers who make sure that they adhere to their principles and are robust and sufficient. There's the users, who is using this AI, in case of DoD, war fighters, soldiers, commanders, and so on. And at the top level, we have policymakers and regulators, and what are they doing about ethical AI? Right? So we have to think about who the ethical AI audience is for our particular each stage along this pipeline of development. Most of our focus has been on this left side, on the development side, because that's what Kitware does, and also that testing side. So the testing and evaluation side of AI to make sure it's compliant with those 5 principles is a big deal. The DARPA Asimov program we'll talk about at the end is entirely focused on this test and evaluation side. So is the JDIG program that we'll talk about. So there's a ton of work going on in testing and evaluating AI systems to make sure that they adhere to those 5 principles or some equivalent. But on the development side, we've also done quite a bit of work in how we make systems ethical. Right? How do we create an ethical AI that is going to be involved in medical scenarios, is going to make critical decisions under uncertainty. Next slide. On the civilian side, NIST, under executive order from Biden that I mentioned, which was published about a year ago, NIST was tasked with creating this AI Safety Institute, which started in January. Kitware joined this, as did a few hundred other organizations. And there have been working groups and meetings trying to define what it means to be a safe and trustworthy AI. So this has been a big success, I think. I would say it is. I think this probably would say as well, given by the level of involvement of companies. There's thousands of people who joined these working groups from these hundreds of companies involved. There's no funding here from the government. This is all on company money and in-kind representation. So there's really no funding behind this, and yet there is a huge amount of involvement in the communities. In fact, I think in 2 weeks there'll be a plenary session summarizing what we've done in this first year. Next slide. So NIST had created the AI risk management framework a few years ago, and this is kind of the civilian equivalent of what the DoD has been doing. This is a policy book, but it lists the potential risks of AI and what you might be able to do about them. There's a couple of tools to help people understand this. So if you're developing a big AI, you can read this management framework to understand how you should develop your AI to minimize risk of the not just ethics, but reliability, unintended consequences, et cetera. And then there's a playbook to help you step through that process pretty readily. So a lot of nice tools out there that have been created. Next slide. There's been additional updates from the administration. We just released one about a month ago, which applied to national security, which said what you can't do in AI. So AI within the security organizations, the departments of the government are forbidden from doing AI in certain areas, and high impact areas of AI were defined there that require additional due diligence. So much more oversight for high impact areas of AI than other ones. And this created a framework for AI governance and management. There's an AI oversight board now that's required from each of these agencies. The agencies include, of course, Defense, but also Department of Commerce, State Department, and so on. Next slide. So a little closer to what Kitware has been doing, the Chief Digital and AI Office has created what's called the Responsible AI Toolkit. This is similar to that NIST risk management framework. The RAI Toolkit helps you as a developer or a tester to understand what it means to be an ethical AI or responsible AI system. So what is it that you should care about? How do you get your project to comply with RAI practices and ethical AI principles? There are two specific tools in this, and these are all publicly available. You can just go and check them out. They're made for anyone to use, not just within the DoD. There's Shield and Dagger. So on the next two slides, we'll go through these. So on Shield, it stands for this: set foundations, evaluate status, et cetera, et cetera. But it's a questionnaire, right? What are you trying to do? And what ethical AI concerns should there be given what you're trying to do? And it's customized to your project. So very handy. The next one, Dagger, is AI risk assessment factors in the context of your project. So what should you be paying attention to, and how should you track it through the development cycle, through the entire risk cycle of use and deployment of the AI. So very handy tools, been a lot of work and thought put into these. They've also compiled a list of other tools. There's a lot of tools out there in the community that have been developed by private industry, universities, and so on. CDAO is funding a specific tool set development called JADIC, which Kitware is a part of, and we'll talk about in some detail what our role is there. So the presentation of this talk is best practices in responsible AI. So here's just a snapshot of what we would recommend. So in addition to all these toolkits, there's these great toolkits out there telling you what to pay attention to and so on. And so distilling some of that out, we just enumerated 4 things to really pay attention to in this area. So almost all of the tools and practices solicit the risks and harms of what you're trying to do. So what are you trying to do? What are you trying to build? Whether you think there might be AI harm or risk or ethical considerations in there or not, what are you trying to do? And so these tools will help you think about things that you may not have thought about before, especially if you're not versed in ethical AI. So what is it that there might be? What kind of societal harms might there be? And these tools will point things out to you that you really might not have thought of yourself, especially if you haven't been in this area. So that's just that enumeration part. And if you're working in anything that is a high impact area, anything security, critical decisions, not just life and death, but important decisions about, say, people's jobs, security with civilian applications like video surveillance, where somebody might get arrested or not based on the outcome of an AI. So those are particularly risky, politically sensitive, can endanger your organization. So these tools, this enumeration process really helps you understand what it is you have to think about and understand and be aware of. Underlying that, you should learn about all these rules and guidelines and policies and how those tools can help you. So there are all these tools that we enumerated here. Specific uses sometimes can require more tools, more guidelines, and things like that. So you need to know what those rules are. In the end, a lot of this stuff comes down to a compliance type of problem, right? In many cases, particularly for the Defense Department, you're required to adhere to this, to 3000.09 if you're building some kind of autonomous system. You need to know what those rules are and follow them. Sustain your awareness. These rules and tools are adapting and changing all the time. So there's a lot of evolution here. It's just a new version of 3000.09, for example, in 2023. This national security memo came out a month ago. So there's a lot of work here. With the change in administration in the government, there'll probably be a number of other changes, perhaps a lot less regulation, but you'll need to know whatever those changes are. And then number 4, this isn't really part of those toolkits and so on, but I would advise everyone to invite discussion on these issues and topics within your project team. So people really get into this topic and they really want to do the right thing and make sure that their system that they're building is doing the right thing and avoiding societal harm, incidental or otherwise. So usually people are excited and interested in getting involved in this topic and building that directly into their systems. Because in the end, these AI systems are built by people. So they're encoding whatever ethical constraints and behaviors the developers had in mind. And if they didn't think about it, then it may not be in the system. And the system might be just really unaware of ethical considerations that should have been built in. But people are usually very excited about getting these kinds of constraints built in. Okay, I'm going to pass the baton over. Oh, I have one final comment. So on slide 23, the first letter of each of these, enumerate, learn, sustain, invite, spells out LC. That's a little bit of a lexical pun because that ethical, legal, societal implications of AI is a DARPA term that's being used across all of DARPA now to encompass all of this work and consideration on ethical AI. So at DARPA now, every new program has to go through what's called an LC review. The program is being formulated. The program manager has to put together an LC statement, I guess, but an LC review that goes with the program review as the program is being approved. What are the LC factors for this program? And based on that, you might have to have some more work in the program to make sure that ethical constraints are being made, whether it's going to fall under 3000.09 or not, things like that. So it's a good way to remember these 4 practices that spells out.
All right, okay. Thank you, Anthony, for setting the foundations for kind of thinking about ethical AI. In the remaining time, I'll try to breeze through these very quickly, and I'll say that we'll try to make the slides available after the webinar. If there's content that you kind of missed, hopefully you can go through it again at your own leisure.
And don't forget about questions. So anytime, drop a question in the questions part, and we will endeavor to answer it here in line as we go.
Sure. So Anthony mentioned CDAO JDIC. So CDAO is the Chief Digital AI Office. JDIC is a program related to AI assurance and test and evaluation, which stands for Joint AI Test Infrastructure Capability. This is funded as a congressional program of record for the next couple of years. And there's really a commitment of around $200 million for this area of AI test and evaluation. And the main objective is really to develop software that will accelerate and enable AI test and evaluation so that the DoD's AI-enabled systems can be shown to be effective, robust, and safe. This really came out of the RAI, Responsible AI Strategy and Implementation Pathway, which was signed in 2022, which really identified a need for kind of AI T&E test and evaluation tools. So the scope of the current program focuses on AI algorithm testing and specifically on the computer vision domain. So covering tasks like classification and object detection. And it was done really to kind of scope down the problem in the initial years, but there is plans to kind of develop AI assurance for other types of AI systems. So as part of the current JDIC offering, there are a lot of different teams developing different tools. So these range from things like for adversarial robustness to data analysis. Kitware is specifically working on two toolkits, which we'll talk about very briefly, the Explainable AI toolkit and the Natural Robustness toolkit. There are also tools for kind of reporting of results, as well as things like model cards, data cards, stuff like that. If you would like to learn more about the JDIC program, they have a public-facing website, which you can find here, and most of the tools that are there are also open source, so they're free to use in your own kind of problem domain. Okay, so the Natural Robustness Toolkit. So the Natural Robustness Toolkit really addresses kind of how to do testing of AI models. So here shows kind of an existing T&E approach. For given, a model, you might partition your available data into training data, validation data, test data. You would, train your model on the training data. You would use your validation data to select certain hyperparameters. And then kind of as a final test of whether or not your model is performing well or robust, you would use the test data. But one issue is that sometimes the test data doesn't cover all of the factors that you care about. And so kind of besides collecting more data, new methods are needed to kind of expand and augment this data to make the kind of robustness evaluation more fine-grained, right? And so here, Natural Robustness Toolkit is really a robust extension to the kind of current test and evaluation pipeline, where you take your test data and then you have this suite of tools that allow you to augment that test data, kind of either in operationally realistic manners or guided by a subject matter expert. And that expanded test data set really helps you better answer the question of whether or not your model is robust. And so here, the Natural Robustness Toolkit, or the NRTK, seeks to be a platform for validated scene and sensor-specific perturbations that can be used to evaluate the robustness of computer vision models. Some of the use cases that we've done is to assess computer vision models at various stages. So either pre-sensor augmentations, at sensor, or post-sensor. So one example might be to measure how changes in your sensor configuration might impact the data collected as well as model performance. And also kind of developing new data sets, augmented test data sets that enable this more comprehensive model test and evaluation. And again, the Natural Robustness Toolkit is open source, so you can find it here on GitHub. One of the elements of the Natural Robustness Toolkit is this physics-based image perturbation pipeline. So we have a tool that models this kind of from light hitting off 3D objects in the world through the atmosphere, through the actual optics of the lens collecting the images, and the sensor electronics that post-process that. So we have a way to simulate this, and then as a result, we have a way to measure, how robust the model might be to small changes in this image formation process. And again, that tool is also open source. It's called the Python-based sensor model, or PyBSM. So how might this work in practice? So given, a source image from a data set that you might be interested in, given some knowledge of the relevant sensor and scene parameters, we can model that accurately and then generate synthetic images that span a larger set of relevant factors. In this case, we're varying the focal length of the sensor and the aperture diameter. We can generate synthetic images of these conditions, and then we can essentially test how well the model might be performing on these images. And that's shown notionally here. Given your test data, given the scene sensor specific parameters, we might be able to compute performance of the model against all of these relevant factors, like presence of motion blur, or the focal length, the target range. Here we show for one model, but we can also put multiple models against each other and do a more comprehensive evaluation of how robust models are. I think in the interest of time, I will kind of just skip over this, but we've tested this on satellite imagery, specifically the XView dataset. We looked at varying ground range and focal length. We can do this kind of evaluation using Natural Robustness Toolkit. And in this case, we identified that increasing the ground range of targets caused model performance to drop. And one of the things that can be taken from this is that we can maybe in the future, a retraining of the model kind of incorporate the synthetic data of these larger ground ranges to hopefully improve the model performance at these ranges. We've also developed a NRTK Explorer app, which is also open source. It's kind of a dataset exploration tool where you also have the ability to apply the NRTK perturbations and assess how that impacts model performance. It's all interactive. It can run either locally or in the cloud. And we're hoping that it serves as a useful way to visualize your data sets, perturb them, and kind of get a sense of model robustness, all in an interactive setting. So again, that's an open source tool. I encourage you to take a look at that. Okay, and next I'll talk very briefly about the Explainable AI toolkit. So why do we need explainable AI? So the traditional learning process, effectively, you take your data, you train a model, and then when you're querying the model, you get an output, but you might not really understand from a user perspective why the model made a particular decision, especially when the model gets something wrong and might have kind of catastrophic impact. Right? So the idea of explainable AI, this field is really to come up with either new learning processes that make the model more explainable, improve upon the model explainability inherently, or come up with ways to, in addition to just knowing what the model outputs are, having an explanation interface or a set of explanations that can provide insight into why the model made a particular decision. And the hope is that from that, the user has a better understanding and trust of the underlying model. And this was work that was funded by the DARPA Explainable AI or XAI program. I encourage you to visit their website to learn more. So from that program, we developed the Explainable AI Toolkit or XAI TK. So this is a platform for visual saliency algorithms to enable human understanding of complex machine learning algorithms. And so some of those ideas that we've been using this for are, for example, enabling future understanding and analysis of black box AI models. So this would be trying to understand what features the model considers important when it's making its predictions. And then when the model does fail or when it encounters an edge case, using the explanation as a way to diagnose what the model has done wrong and maybe kind of fix it in future iterations. And again, Explainable AI Toolkit and the XAI TK CNC package specifically, these are also open source tools that you can find on GitHub. So the Explainable AI Toolkit is more or less a central repository of artifacts and capabilities from the XAI program. This includes data sets, kind of reports guidance, a large set of publications, and as well as kind of software and tools. And these were mainly split between analytics capabilities and autonomy capabilities. And XAI TK CNC falls under this kind of analytics section of capabilities. If you go to the XAI TK website, which is at xaitk.org, you'll find this landing page. And then for each of the capabilities, there's a separate page that describes the intended use and has pointers to either papers or codes that use that particular capability. So I encourage you to explore that more. At Kitware, we've done a lot of work on saliency maps, which are a form of visual explanations. I think this is one of the most mature areas that came out of the Explainable AI program. So saliency maps are a heat map which localize, in terms of the input image or the input data, what the model focused on when it made its prediction. So in you can apply this to both image tasks as well as text-based tasks. And then here we make the distinction between white box and black box, depending on how much access you have to the model internals. So white box means you can actually know the model structure, the model parameters. Black box does not assume that, and effectively you only can get input-output pairs. At Kitware, we've used Explainable AI for a wide variety of use cases. I will kind of skip over that, but encourage you to look at our papers and work in this area. And here, we've also looked at Explainable AI kind of in the model test and evaluation use case. In this case, we're looking at aerial imagery from the Visdrone dataset. We can compare two different models, a YOLO-based model, a ResNet-based model. Here on this sample image, they get very similar detections, but we can actually look at the explanations in the saliency maps to see if they actually use similar strategies. And so that's what we did. We computed saliency maps for the outputs of both of the algorithms. So the YOLO model is on the top row, the ResNet model, CenterNet model is on the bottom row. We show that although the saliency maps are similar, the YOLO model actually uses more fine-grained parts-based features, which you can see in some of the examples here. Specifically focusing on like this car class, you can see that this YOLO model tends to use side view mirrors as one of the main features that it cues off on that you don't see kind of in the CenterNet model. And then we can also maybe use saliency maps as a way to measure how well the model does on a particular class. So in this data set, the bus class is relatively rare. And so the YOLO model was better performing on the bus class. You see the saliency maps are more localized, while in contrast, the CenterNet model, they're more diffuse and not focused necessarily on the object. So here, as just a summary, we can use saliency maps as part of the model test and evaluation process. And here we showed that in correlation to the model performance, the YOLO model seemed to have a different strategy that was revealed by the saliency maps. We also have a GUI tool, which you can find XAITK Saliency web demo, that allows you to upload your own images, choose a model, and then generate explanations of that. Encourage you to check that out. We had a demo, but I'll skip that in the interest of time, and then jump briefly to kind of the leading question we motivated, would you trust AI to make medical decisions? And so one of the programs we worked on is this DARPA in the moment program. The main objective is to really understand human decision-making in difficult scenarios, such as like when you're trying to allocate treatment on the battlefield, and then whether we can encode those same human values and decision-making attributes in AI algorithms that are designed to make these difficult decisions. And then the plan here is to really study human-aligned AI agents and their interaction with trust, and then really understand also whether humans are able to delegate, are willing to delegate to AI. We work with a really great team of academics and industry partners. I won't dwell on this slide very much, but many of these are premier academics in this kind of AI natural language alignment space. Yeah, I'll skip this overall concept, but generally, given a scenario, we pass this to our algorithm and we ask it to make an explainable decision. And we want to focus also on the multi-valued alignment because we want to consider trade-offs between values and how that would impact both human and AI decision-making. As a first step, we worked on a simple data set that we developed in the medical triage domain. We looked at a couple of different decision-making attributes, which are shown here. And we partnered with one of the other ITM teams to develop this data set. We developed a zero-shot LLM-based approach to align the LLM's output decisions according to these different attributes. So in this case, we are targeting something like high fairness. We give this scenario with a set of choices to the algorithm. We sample from the algorithm multiple times to generate a consistent decision aligned with this particular attribute. And we also, from the model, are able to generate an explanation of why the model chooses a particular decision conditioned on the attribute it's focusing on. In terms of the quantification, we explored a set of base models. Here, this is a radar chart showing alignment to either the low or the high levels of each attribute, continuing care, risk aversion, a moral desert or moral judgment. Here, the baseline models generally show performance around 50% alignment accuracy. When using our zero-shot method, we're able to improve that and increase the alignment accuracy. I'll skip this one. And just as a kind of future-facing work, we are collaborating with the University of Washington. They have a long kind of line of work in studying value pluralism, effectively how AIs can represent multiple potentially conflicting values. And so we're using their approach to kind of capture that multi-valued decision-making in the medical triage domain, and then trying to build off of this framework to better model those trade-offs and kind of build AI systems that understand those trade-offs and those diversity of values that might be encountered in any given scenario. So if you're interested to learn more about their work, they have a recent paper on this. Yeah, so I'll pass it back off to Anthony to describe, as he mentioned, this Asimov program.
Okay, thank you, Brian. Before I do, we did get a question.
Okay.
And the question was, how can we create realistic and authentic conversations on these topics? There's a tendency for a bit of bipolarity where we have fully perhaps naive techno-optimism or really dystopian aspects. I think that what we've observed over the last set of programs we've been on here is that the technologists the developers are realistic because they have to build something. And they often didn't think about things like defaults. And that's a simple thing to change, but it can actually make a big difference. We were on a DARPA program that had was trying to estimate whether civilians in a population were benign or hostile to an approach of, say, U.S. forces in a potential war zone. And the default was 50%, just because that's what the developers do, right? We just say, we don't know, so it's a flip of a coin. But it was 50% really a good estimate? I mean, that's estimating that amounts to an assumption that 50% of the population was actually hostile, whereas all prior data was more like 3 or 5%. Right, so just a simple default like that probably should have been 5% as the prior, and that prior was used as a prior probability, which then influenced all these downstream computations. So when we make it concrete for folks, then they tend to really see the balance. The other aspect, which really comes up here in Asimov, is you have to have some factor in any of these ethical considerations, and all the way down to computations, for accomplishing the mission. So it is a military setting that we're in here for Asimov. So I'll talk about that a little more and hopefully answer this question. But mostly it's when we come down to actual circumstances and we show developers, it's on the development side, what it is that we need to do and what's realistic to get done, then it tends to be pretty grounded, and we can end up in that middle area where we're explicitly coding in these trade-offs of how much tolerance you're going to have for civilian casualties, for example, which is what people think about anyway when they're doing it. But now, how do we encode that into an AI, into an algorithm, in a computational framework? So the Asimov program, Kitware is a performer on this. It just started up. So these slides are from the proposers day from DARPA. I'll cover it just a little bit, and then we'll close out. Next slide. So it's literally based in some conceptual way on the Asimov's 3 laws of robotics, and the 4th one, if you count. The next slide. So Asimov is not developing autonomous systems or autonomous weapons or lethal autonomy. Instead, it's developing a way to measure how well an autonomous system complies with the 5 DoD ethical AI principles. So shown here on the right, we have this radar plot, the 5 principles, it makes a pentagon, and how much does one AWS comply with those principles, where full compliance is on the outside, depending on zero compliance is on the inside. So we can measure each AWS in principle against those 5 principles and then score it. So how do we do that, right? How do we take those 5 principles and actually make them computable and measurable? That's what Asimov is about. So we're not developing the systems, we're using existing autonomous weapon systems, all in simulation, and then creating a framework by which we can measure them against each of these 5 principles. Next slide. So this is generally aimed at the testing community in the center here, right? So we are not developing AWS systems, but we are helping the testing community understand whether an existing autonomous weapon system can be fielded. Can it apply, can it meet sufficient ethicality levels, which we call autonomy readiness levels, against these 5 principles, such that it'll pass the 3000.09 regulation for autonomy that I referenced earlier. And 3000.09 does require now adherence to these 5 ethically high principles. So it all lines up, right? So if you use Asimov and it will measure how ethical your AWS system is, then that should demonstrate compliance with 3000.09. Next slide. So that was a little brief bit about Asimov. And just to close out, to reiterate our best practices, Asimov, by the way, is a 1-year program with a 1-year option. So a 2-year program that just began. I encourage you to follow up with me if you want to know more about it or about any of the programs that we're talking about here. So again, just to reiterate, enumerate potential risks. Number 1, ITM is lewingness and this human-aligned decision-making. What do humans think about? What sort of ethical aspects would humans actually use? Item 2, learn about existing tools, guidelines, policies. Asimov is a computational thing. It will produce computational systems that will measure how ethical your system is. And also, it'll tell you what to look for. So when you're building a system to pass Asimov's ethicality test, its autonomous readiness level, you will know what it is it's going to measure. So you will be able to say, I need to put those things in my system. So it's really a blueprint for how to build your system to pass the test. The sustainment of your awareness. Tools coming out all the time. We have open source toolkits, they're evolving. This field is evolving very quickly, so it really does require a bit of constant attention to keep up. On the invitation and debated discussion, we found it to be super useful to have the developer teams involved right from the beginning to understand these issues. There's training on responsible AI that you can get from a variety of organizations, and including even NGA, for example, has a responsible AI training course for their own people. So people love to talk about this. When you get them excited about it, then you'll end up with a system that's much more likely to pass an Asimov kind of test or any sort of test to show that the 5 ethical AI principles are met. Next slide. Reach out. We have a number of links in here in the presentation, in the slides. I think the slides are going to be available. Of course, they're publicly released. XAITK and NRTK are 2 of the things we reference in here, but there's a lot of other policy documents and so on. I did want to answer the one question, make sure we answered the question that we had. If there's any other follow-up questions, any other questions in the chat? No, I don't see any other questions, but I do believe we'll make the slides available. And I thank you all for attending. Feel free to reach out to me, Brian, Kitware in general about any of these topics. We have a lot of active work in this area. We're always interested in finding out what other people are doing, what other needs there are, and other opportunities to develop more on computational frameworks for ethical and responsible AI. Oh, one late-breaking question. What do I think is the future of explainable AI? A great question. So explainable AI traditionally has been a bit dependent in many ways on what the AI models under examination are. For example, many explainable AI methods that do visual saliency, as Brian talked about, are white box methods that look into the network and see what parts of the network were activated, which corresponded to some part of the input. So which part of an image, how that activation flowed through the network. That's called a white box method. We did black box methods. I think as the AI becomes more and more complicated, we'll see more about black box XAI methods. Most of them are honestly white box. But XAI is grappling with this very, very difficult problem of enormous models, and it's not very practical to do white box methods anymore. So I think we'll see a shift towards more black box methods. And in particular, LLMs, they can explain themselves, right? You can ask an LLM to justify a decision it made, to explain its reasoning, and it will produce something. The difficulty is you don't really know if the explanation that it produced was actually the right explanation. Is that really what it thought about? It might give you a decision about A, and you say, you ask the LLM, well, why did you decide A versus B? And it might enumerate reasons alpha, beta, and gamma. But did it really use alpha, beta, and gamma when it was deciding A versus B? It's very hard to know that. That potential disparity is called faithfulness. How faithful is an explanation to the model itself, and how do you know that? It's very difficult for LLMs because it's very difficult to know in detail computation exactly how they made a particular decision. So I think there's going to be some exciting research in this. There's a lot of work in localizing knowledge within LLMs, which will help a lot with explainability.
It looks like Olivia has a follow-up question. It seems like there are a lot of shortcomings, especially with post-hoc explainable AI, such as stability. And she gives example of small changes in inputs can cause large changes in explanations and fragility to manipulation. What are your thoughts on how to address?
Yeah, that's a great question. It goes back to this faithfulness. So XAI is an algorithm. So to do an explanation of a particular model and decision that it made, we literally, in our case, we created these black box algorithms to do that. And it's like any other algorithm. It could be wrong. It could be, it has its own characteristic and its own results. So again, how do you know it's faithful? So I think in any algorithm, an XAI algorithm that is unstable is probably less faithful. Right? So when you change the input a little bit, how much does the explanation change? It's possible that the model is changing that much, but I think really the research there is to understand whether it's really the model changing or is it the XAI algorithm changing. I think there's been some research on that, but that's where I would really look is how stable is an algorithm for explanation versus the underlying algorithm that you're modeling. And that can be done by various types of cross-fold analysis and things like that might help.
See,
All right, any other questions?
not seeing any more questions.
Okay. Nope, Katerina's question. How do you differentiate between explainable AI and mechanistic interpretability? Brian, do you have an answer on that one?
Yeah, I think mechanistic interpretability is maybe a subset of explainable AI. I know mechanistic interpretability is very popular nowadays with analyzing, the internal workings of LLMs. So yeah, I think they are related. I think it's kind of the level of detail you want to get into in terms of your explanation, and also, yeah, I think it's an active area of research. So I think it's an exciting time to be studying these types of things, especially with the rise of like generative AI, larger models, and multimodal models, which might take into account multiple, images and text domains, where previous explanations really focused on just one domain.
Yeah, that last point, multimodal models become much more difficult for explainable AI. So if you have a vision language model, it knows about visual data and text data, and it's brought them together, like CLIP is the classic multimodal model, but now many of the LLMs have multimodality. An explanation now needs to understand and dive into potentially both of those underlying representational aspects and the fused component of them together. So that is a much more complicated problem for explainability. There are some nice research papers on this that have come out in the last year or two. So I think the XAI community is starting to grapple with these vision language models, but it can be considerably more involved. Okay, well, I think we'll close it there. Thank you very much for attending and for the great questions. And again, reach out as you can. We're happy to discuss further.
Thank you all.
All right, thank you.